All right, so in Cisco ACI, we love using VRFs, right? They're like these perfect, secure walls we build around our apps. But what happens when you need to poke a tiny, very specific, super secure hole in that wall? I mean, how do you let an app in one tenant talk to, say, a shared DNS server in a completely different tenant, all without just blowing up your security model? Well, today, we're going to dive into how ACI solves this really tricky routing puzzle with one surprisingly elegant tool.
So here's what we'll cover. First, we'll tackle the why, the whole isolation problem to begin with. Then we'll pull back the curtain on ACI's secret weapon for this job, the contract. I'm going to show you the two absolutely critical settings you cannot forget. Then we'll actually walk through a configuration. And finally, we'll look at how you can take this basic design and really scale it up. Okay, let's start at square one. Why do we even need to talk about something called route leaking? Well, the answer really comes down to one of ACI's most powerful, fundamental features, that awesome total isolation you get with VRFs.
So by its very nature, ACI uses VRFs to build those walls we talked about. You can just think of them as virtual routers. So tenant 1 and its VRF, they exist in a totally separate universe from tenant 2. I mean, they have their own independent routing tables, and by default, there is absolutely no way for traffic to cross between them. And you know what? For security, for multi-tenancy, this is fantastic. It's exactly what you want.
And there's always a but, right? This perfect isolation, it creates a brand new problem. What happens when your app over in tenant 1 suddenly needs to talk to some kind of shared service? Think about it. Maybe it's your corporate DNS, or an Active Directory controller, or maybe a central database that tons of apps need to hit. How in the world do you bridge that gap without just tearing down the very security model you just built? And this is where the magic of the ACI policy model really shines. Seriously, you can just forget all about those complex route maps and those super messy access lists you're used to from traditional networking. ACI takes this whole problem and boils it down to one single, incredibly powerful object. Now, this is probably the most important thing to get your head around. In ACI, just one thing handles both the security policy and the route sharing. It controls who's allowed to talk, and it also tells them how to find each other. And that one thing, it's the contract. So here's the crucial part. A contract in ACI is doing double duty. Yeah, most of the time we think of it as just a firewall rule set, right? It defines the protocols and ports allowed between our EPGs. But, and this is the key, when you configure it in a specific way, it's also telling the ACI fabric, hey, you also need to share the subnet information for these EPGs between their different VRFs. It's your security and your routing all wrapped up into one neat package. Okay, but to unlock this amazing dual functionality, you have to flip two very specific switches. And trust me, if you get these wrong, nothing works. It just won't. So let's take a look at exactly what they are. Here they are. These are the two essential puzzle pieces. On the left, you've got the contract scope. Now, by default, this is set to something private. When we set it to global, it's like we're making a public announcement that the entire fabric can see. Then over on the right, you see the subnet flag. By checking that shared between VRFs box, you're basically raising a little flag on that network and telling ACI, hey, this one is special. It's allowed to be shared. You absolutely need both of these for the magic to happen. So let's just hammer this home for a second. Why do these two settings matter so much? Well, setting the contract scope to global is what lets tenant 2 even know that a policy object from tenant 1 exists. Now, if your VRFs were in the same tenant, yeah, you could get away with a more limited scope, like tenant. But for cross-tenant, it's gotta be global. And that shared flag on the subnet, that's the direct, explicit instruction to the fabric's control plane. Without that checkmark, ACI just assumes, nope, this subnet stays private to its own VRF, and it won't care what the contract says. All right, theory's great and all, but let's actually get our hands dirty in the APEC. I'm gonna walk you through the few simple clicks it takes to actually connect our two tenants. And look, the workflow is actually pretty straightforward. We're going to define the networks, we'll create that global contract, then we'll tell the provider EPG to provide it, we'll export it to the other tenant, and finally, we'll tell the consumer EPG to consume it. Simple. Let's do it. First things first, we're on the provider side. Now, this is a really important point because we want to tie the specific subnet to the service that this EPG, the endpoint group, is offering. We configure the subnet right here, under the EPG itself, not under the bigger bridge domain. And then, of course, we check that magic shared between VRS box. Okay, next up, the contract itself. We'll go ahead and create a new one. And look, here it is again.
that absolutely critical setting. We've got to flip the scope from any of the private options to global. That's what makes it visible everywhere in the fabric. Now it's time to tell EPG1 that it is the provider of the service. We just go to the EPG and we add the contract as a provided contract. And just like that, EPG1 is officially open for business, offering up its service to anyone who's allowed to use this contract.
But wait, Tenant 2 doesn't know about this contract yet. So we find the contract back in Tenant 1, right-click it, and select Export to Tenant. This doesn't actually copy the entire contract. Think of it more like it creates a shadow copy or a pointer over in Tenant 2. This just lets the administrator over there know, hey, this contract exists and it's available for you to use. And for the final piece of the puzzle, we jump over to Tenant 2. Now, when we go to our consuming EPG, EPG2, we add a contract, but this time it's a consumed contract interface. We pick that contract we just imported, click Submit, and that's it. The connection is made.
And this right here, this is the beautiful result. That single global contract has now told the fabric to do two things at once. First, leak the necessary subnet routes between VRF1 and VRF2, and second, apply the security policy to actually permit the traffic. Our initial isolation problem? It's solved. Cleanly.
Now, this one-to-one connection is super powerful, for sure, but the real beauty of this ACI design is how incredibly scalable it is. So let's see how this simple building block can be used in a much more complex, real-world kind of scenario. Just take a look at this. We've got a central common tenant that's providing two completely different shared services. Each one has its own global contract. Over here, tenant Y is consuming one service, and over there, tenant Z is consuming the other. But the exact same principles we just walked through apply. For every service you want to share, you just create a global contract and flag its subnet as shared. It's so clean, it's repeatable, and man, is it scalable.
And this brings us back to a really critical best practice. Remember how I made a point about configuring the provider's subnet under the EPG, not the bridge domain? Well, this is exactly why. If you had just defined both of those shared subnets under the one bridge domain, they would both get leaked to both of the consuming VRS. You'd end up with a really messy routing table. By tying each subnet directly to its specific provider EPG, you guarantee that only the right subnet gets leaked to the VRF that's actually using that service. It keeps your routing incredibly precise and clean. So there you have it. We've taken what was a hard, isolated boundary and turned it into this flexible, policy-driven bridge. And we did it all with a single ACI object. It's a fundamental shift, really. You're moving from manually configuring routes to simply declaring your intent. So now that you have this powerful tool in your toolbox, think about your own network. Where could you break down a complex, messy firewall rule set and replace it with a super clean, scalable, shared service design like this? What are you going to build first?